recording. The last time we talked about real-life data and how to make confidence intervals with real-life data. We had these prices for bottles of wine, and then we did stdev.s to get the standard deviation, and then also average to find the mean. And we found that the sample mean was 14, and the sample standard deviation was 14.89, and then n was 36. And then what was the problem with trying to construct a confidence interval? There was something missing from the confidence interval formula. Sigma. Yeah, sigma. So sigma was missing. So what were we going to use instead of sigma? What approximated sigma? Good. Sample standard deviation, very good, both of you. Sample standard deviation, S, is the sample standard deviation. And it's better to have sample standard deviations that come from high ends. Well, we need a formula for the sample standard deviation. That's going to come into play. Does anyone remember what the formula for sample standard deviation was? Let's go through our notes and see if we can find it and write it here. Yeah, don't worry about copying this down. I'll take a picture of it and I'll just email it to everyone. So let's go ahead and see if we can remember what our sample standard deviation is. Okay, we need to form some groups here. Audrey, I want you to come up to the front and work with Ava for me, please. And then Hannah, since you're super close with the other Hannah, if you want to work with other Hannah, and then I'll have David come up to the front and work with Alina. Let me know if I'm inaccurate on that. I just know that you guys came in like the first day together. So let's see if we can remember what our formula for sample standard deviation is. That part's right. Good.
And is this number of sample, like number of people in the sample on the bottom?
Yes, the number was n-1 at the bottom. Does that look a little familiar? Alina, you have the newer notes. We're still finishing the notes.
I know exactly.
So it's for a sample, right? Not a population.
Yes.
Good stuff.
Good. You remember the n-1 on the bottom? That's good. So I have a couple of people already filling things in. They remember that there was an n-1 on the bottom here. What symbol goes on the left? What's our symbol? Good, S. So just finishing the top off. We take the mean away from each of the values, and then what do we do after we take the mean? Square it.
Sigma x.
It's sigma x minus x bar, the whole thing squared. That's our formula for sample standard deviation. Now, the only reason I bring this formula up is because first we're going to need to calculate it, but what's the little shortcut to calculating this if we were doing it in Excel? How do we just do this? Good, or stdev.s of your sample data, as we did last time. That's a shortcut. But when you do stdev.s, it doesn't remind you that there's an n-1 at the bottom here. This n-1 is going to be important. So we're going to talk about that in just a bit. But another thing we have to talk about is the C alpha over 2 symbol. So a lot of us, we were constructing the formula for the confidence interval. We found that the sample mean was 14, and then we found the margin of error. For 99%, we took the 2.58, and then we multiplied it by, I saw Lauren's group doing this last time, the 14.89, and then dividing it by the square root of 36. What's the problem with this, though? What did we have before? We didn't have a 14.89. When we had that real population standard deviation, what was it? You guys remember from the previous notes? That was the mean.
21.
21, very good. So really, in order for this to work, there's supposed to be a 21 here, not a 14.89. So because we changed the 21 to a 14.89, because remember, we don't know 21. If we knew 21, we would put the 21. We don't know it, so we're putting the 14.89 instead. The problem is, this value is no longer accurate. If we change the 21 to a 14.89, we can no longer put a 2.58 here. So I'm going to cross that off. We're going to have to change the 2.58 as well, because that's going to tell us that there's a 99, we want there to be a 99% chance here. In order for this to be a 99% chance, we can't use that 2.58 anymore.
Is it either the 2.58 or the 14?
Exactly. If we're going to use the 2.58, we have to use the real population standard.
So then if we use the 2.5, if we use 2.5, we use the sigma.
Exactly. So because we don't have it, we don't have the 21, we're changing it to a 14.89, so then we have to get rid of the 2.58.
Then how do you find them?
Okay, we're going to talk about that. We're going to use something, we're going to skip question 5 because I think I've pretty much talked about that already. We're going to use something called a T alpha over 2 value instead. That's going to be the alternative, the T alpha over 2 value. And the T alpha over 2 value uses the sample standard deviation instead of the population standard deviation. So I want us to just write a note here that says uses sample standard deviation. Yeah, okay, it is, or sample standard deviations. That's true, that is the blank. Okay, you're right. I guess I'm filling all the notes in. So in question 5, if you want to know what question 5 represents, it would have just had population here instead of sample. Basically, population standard deviation goes with the Z alpha over 2. And what goes with the T alpha over 2? Sample. Good. So population goes with Z. Sample goes with T. So that's really the only difference. Very good. So that's probably the highlight of the day, if you want to take notes on that. What goes with the Z? Population standard deviation, and T goes with sample standard deviation. But the problem with the T distribution, and I didn't spell distribution right here, just ignore that typo, is that there may be more than one standard deviation. Okay, let's go ahead and match each of these symbols to how many we think there are. We already know that the S and the T go together, and that the sigma and Z go together. But there's part of the reason why these go together is because with sigma, there may only be one, or there might be one for every single sample size. Same thing with that. So let's go ahead and match each of these to what we think. You like working by yourself? We need to work with money. Okay, what did you guys say here? Exactly. Very good. You guys tell that I'm like linking the S and the T together just so you guys know where they're at. Okay, so let's take a vote. With sigma and z, there is how many? Okay, I'm giving away the answers. There's only one. Why is that? Good. How many populations are there? One. Very good. What about samples? How many samples are there? Good. Did I say there's one for every sample size? Yeah, in fact, even this is not the most accurate statement. You could have two different samples of size 40 that are completely different. You can have 5 different samples of size 30 that are completely different because you chose 30 different people in each sample. But the main thing that's important is that there's a different one for every sample size. So how many t-distributions are there? There's one for
Every sample size.
every sample size. So if you're going to type in things like t.dist, you're going to have additional values to type in. We're going to be typing in things like t.inv. When you did norm.s.inv, you just put the area. In this case, we did the 0.99. Am I going to be able to just stop there if there's a different t-distribution for every sample size? Then you're going to have to put comma, and then you're going to have to type in that additional value. So we're going to talk about what that additional value is. Okay, first we have to say, is there a t-distribution for n equals 1? And I want us to look at the sample standard deviation formula, because remember that the t-distribution goes with the sample standard deviation formula. Why is there no t-distribution for n equals 1? Think pairs share individually.
Zero at the bottom, 0 or 1 minus 1 is 0.
Here, I did say to do this individually first before discussing with the partners, but that's okay. I think we all know the answer. What's the answer?
1 minus 1 equals 0.
You can't divide by
Good.
zero.
If n is 1, you're going to have a problem. 1 minus 1 is 0, and you're going to have 0 on the denominator. So you can't have a t-distribution for n equals 1. But you can have one for n equals 2 and n equals 3, etc. Any questions on the t-distribution? Okay, very good. Just like z, or blank normal distribution, uses the Excel functions. Okay, so these are our two Excel functions for the z distribution. This blank here just says, what is the alternate name for the z distribution? And then for the t distribution functions are basically just like dot dist and dot inv. Let's kind of speculate what all three of these blanks should be. Again, individually, then partners, and then we will discuss it as a group.
You should write.
Oh yeah, well just if this is a hint for the problem, totally use it to help you fill in the blanks. No, I'm not a trickster.
Just sometimes.
It's not intentional, I promise I'll work on that. Okay, good. So The t-distribution uses what dot dist? T dot dist and T dot INV. So those two were the easy ones. Okay, what's the z distribution? What's another name for the z distribution? Norm dot S. What do you think?
Sample.
Very, very close.
Standard.
Standard. It's a standard normal distribution. It's been a while since we've gone over that. Okay, so now what I want us to do is I want us to find the 5th percentile for the z distribution, and then also for the t distribution with a sample of size 2, a sample of size 30, and a sample of size 100. Now, the reason why we're creating a new column called degrees of freedom is because we have a sample of size 1 for the t distribution. No, so we start with 2, which we call a degree of freedom 1 because we want our degrees of freedom to start with 1. And basically what we're doing is we're just taking one value off the 2 here to get the 1. Just like we always do when we find sample standard deviation. When we find sample standard deviation, we always take 1 off of the sample size. So this is the same thing here. We're just calling it degrees of freedom. So I want us to fill these in and then find the 5th percentile in each of these.
Wait, I have a question.
Yes. Yeah, that's right. Yes, you always do inverse for percentiles, yes.
How do we, so what do we do? Are these right?
That's right. So we use the .ind to do the, let's do it for the z first. You're going to do it with the z to find the 5th
Wait, how do
percentile
you
with
find
the
the
z.
degree of inverse? Oh.
So remember to do the 5th percentile, we did norm.s.inv of the area to
So would this be T dot INV of 1?
INV of the percentile, which is 0.05. So the 5th percentile would be
Oh,
the area to the left, which is 0.05.
and then comma 1.
Yes.
Comma.
This would be.
Because 0.05 is the probability and then the degree of freedom.
Z.
Again, of the area, which is the area to the left is 0.05.
Degrees of freedom is just sample size minus 1, right?
Yes.
Yeah. Bless you.
So this one is the z, which is norm.s. The t goes for these 3. So that one should be in that document.
Oh, never mind, that's the last.
I'm not sure, so this would just be 29 must be.
Yeah, the only thing that's changing is this one. Yeah, that's good. The degrees of freedom is just 1 less.
So it's like, and then there is.
Well, this, do it like a, just make it easier. That's all the 2 dots.
And the 5th percentile is written at 0.0.
Oh, because you're not on Excel, you're on.
The Google one, yeah, I don't have it.
Or,
different.
oh, so what you do is you plug in like a 0.05, because that's like probability.
That's the percentile.
Percentile, sorry. Comma, your degree of freedom is all one. And that's
Doesn't get a Z.
Oh, okay.
Thank you. Yes.
So for the Z, we do norm.s. Okay, let's go ahead and go over the answers. So to find the Z degrees of freedom, or sorry, there's no degrees of freedom with Z. I'm confusing myself. To find the percentile, this was a problem on the test. How did we find the 5th percentile on the test? Norm dot S dot INV of 0.05, and that's it. We're done. Do we have to enter degrees of freedom for norm dot S? Did we ever enter degrees of freedom for norm dot S? No. So negative 1.64. So that's the answer to this one, negative 1.64. Okay, next we want to do this with the t distribution and 1 degrees of freedom. Again, t.inv. What am I going to put for the probability? What does it mean to be okay? Percentile means the area to the left is 0.05. That's what a percentile means. The area to the left is 0.05. So I'm going to put 0.05, and then the degrees of freedom is 1. I get negative 6.31. What are the degrees of freedom for a sample of size 30, 29, and for 100, 99? We just take the value. I'm going to have you guys do those on your own. It looks like most of you guys were doing it. When do we get similar Z and T? Was it similar for 1 degree of freedom? Are these similar? No. What for 99? What, were they similar for 99?
Yeah.
Yes, so when are they more similar?
The hardest.
Good. Excellent answer. That's all its questions ask.
So we'll read off what they got for $29.99. I still have my laptop.
Oh, it's negative.
You can announce it to the class if you want.
Are you looking for the moment?
Yeah. Oh, you do?
Okay, any questions before we move on to the 99% confidence interval? Okay, let's go ahead and find this 99% confidence interval. So if we go back to our formula, here it is. I crossed off the 2.58. So change the 2.58 now based off of the t. Hence, n equals 36. I'm going to write it down here. Don't forget that in this problem, n is 36. S is 14.89, and X bar we have over here. So let's go ahead and see if we can change the 2.58. We're using what distribution?
99.
T. Using the T distribution of 99% confidence. Draw pictures. Draw pictures. Draw pictures. It's a 99% confidence. We also want to draw the normal curve with 99% in the middle. Yes. And so then how much do you know on each side? It's like 9%.
Do we
Yeah, but you don't need that for the t-value. You just need the sample size and the area. This should be 0.01, and when you divide 0.01 by 2,
It says we're doing the same as this one.
that's what's on this number.
So we put it close.
And then we're using t instead of v. So before you would do norm dot x dot. Which is what norm dot x dot. The ID. You were using Excel for those problems, right? Remember that you put this here. The only difference now
Of the
is
t
we're
inverse.
using t. So we're going to do, what do we use instead of norm dot x dot? T dot.
No, do we need to do something else? I think we have to. Yeah,
We're
what's the
either
degree?
using norm dot x, one is 15.
Wait, there's 36, so maybe it's 35.
Yeah, maybe.
Try 35.
Some
Maybe
antlers.
That's 0.005.
it's 70, is it 72? 72?
Negative 2.
Okay, what am I getting for RT
So then that is what we plug in
What did you plug into?
instead of.
We do the that times.
Oh.
We have the sample size.
Yeah, it's the same.
Same as that,
Oh,
so.
wait, instead of 8, 9, we're gonna do 14.6.
So you have 99% in the middle and you have 0.005.
Oh, 5, it's 0.99.
Are we gonna do the negative one now, or are we gonna
Or it's negative 2. But then you do the positive, you do the 0.99, so you do like, and you're doing the area of like this instead of just, you know. Okay. So you can always like do that, it's a positive, or just do the 0.99 plus this.
Exactly, yes.
It's always the positive number, it's never
So-
like 17. Okay.
We could probably just use
Okay.
positive one, I think.
Yeah, we got that wrong.
So 2.72. 2.72 times.
I don't know, I don't have the answer.
I just did it like, I did it
Divided by
as.
square root of 36.
Yeah, that's right.
Right, but that's like.
Where'd you get 14.6?
2.72, I think that's correct. You guys also got 2.72.
Positive or negative?
Use the positive
What do you do
one.
with the negative?
I guess for the margin of error, 6.6.
Yeah, I think that's correct. Good, good. Okay, very good. So far, almost everyone has gotten it.
Subtracting out of 14, find the confidence interval. So 14 minus 16.6. 7.34. And then it goes 14 plus 6.66 is 20.6. This is the.
Okay, let's draw some pictures. Pictures are super important. If we have 99% in the middle, how much do we have on both sides? Okay, this is the important part. It's 0.005 on both sides. So if we want to find this t-value over here, I have to put this entire area in. What's this entire area? Good. 0.995, comma, degrees of freedom. What's our, if our sample is size 36, what's our degrees of freedom? Good, 35. When you do that, you get 2.72. So that's our answer. Is it wrong if you do t.inv of 0.005, comma 35? No, just gives you negative 2.7. Either of these are correct. Okay, now we have this, so we can change this here to a 2.72. And then I want to find my margin of error by multiplying the 2.72. I'm going to do equals 2.72. I'm going to multiply it by the 14.89 divided by SQRT of 36. I get 6.75 for my margin of error. How many of us got 6.75 for our margin of error? Okay, good. What do we do now with the 6.75? Okay, good. So we have 14 minus 6.75, and then we have 14 plus 6.75. This is 20.75. And this one here is 7.25, and the mean has to be between these two values. Any questions on how I got the 7.25 and the 20.75? Let's see if you guys got this because you were asking.
Yeah, we were on a little off. I think I just rounded wrong.
Oh, you know, it's probably me because I rounded a lot. I rounded the 14 point. Or did you round the square root of 36?
No, we did 14.6. We did 14. We did.
Oh, yeah.
Oh wait, it is 6.75.
It is.
I just got decimal wrong. Yeah.
Okay, last chance to ask questions before we move on to a completely different section. What's the only difference in this section is we use what distribution?
The T distribution, can we do that when it's the true mean, like it's the true mean price?
But we're always trying to find the true mean price. We use it when we have the sample standard deviation.
So we use S dot inverse, the original one we're doing over with homework. We do that when we give a sample sample standard deviation.
So very good observations. When we use T when we have population or sample standard deviation.
Oh, population.
Okay, let's do a poll everywhere question. Okay, get out poll everywhere. So I'm not 100% convinced that we're clear on this. I'm just going to create when do we use T? When we have sample STDEV or when we have population STDEV? Create. It's Ryan Lowenstedt 013. Don't ask me why it's Lowenstedt. That's not my last name. My last name is really Lowenstedt. Oh, I put it on. Okay, don't be persuaded by other people's answers. For all we know, everyone could have been wrong.
That's true. Right,
Okay. Okay, good. That's correct. Very good. We use T, we have sample standard deviation. How do we find sample standard deviation again? STDEV dot S. Okay, when do we use norm dot S?
population.
Good. If it was you reverse when you use norm dot S. Norm dot S, you use population standard deviation. Okay, good. I think I'm moving a little slow today. Okay, let's now do section 8.3. We're going to now talk about confidence intervals for the proportion. So we're going to kind of move a little bit quickly through the first page because I want us to get to the end of the lesson today. Okay, so I'm going back to value, regular, and peak tickets from Disneyland. Remember that value was 97, regular was like 117, and then peak was like 136, I think. Doesn't really matter too much. Now we're going to look at something called the proportion, and we're looking at the proportion of prices under 100. Is V under 100? Yes. Whatever. So right, this one's under 100. Are the second two prices under 100? No. Okay, what we mean by the proportion of prices under 100 is we're gonna decide if it's under 100 or not. For the samples of size 1, we have the first sample is V. Is V under 100? Yes. So we're gonna write that it's one value that's under 100 over one value total, which is 1. What about, we're trying to decide whether we're going to count it as a 0 or a 1. And P hat is the sample proportion. So we're looking at samples of size 1, V, R, and P. So in this sample of size 1, this value is under 100. So it's 1 out of 1 value total to get 1. That's a good question. What about for R and P? Good. This one's 0. 0 values under 100 out of 1 value total, it's 0. P, again, is 0 value under 100 over 1, again, is 0. So let's go ahead and construct the probabilities for the first two.
0.66 and 0.3.
Yes, that's correct.
Sorry, I came back with that one.
So,
I'm gonna write these down.
So for the value, it's 1 value under 100 over 1 value total, so that's 1.
So wouldn't it just be 0 over
or
1?
so,
It'd be
since there's
0.
only 1, this is just 0 out of 1, 1 out of 1. So 1 out of 1 here.
So this would be
less than
considered a
100.
1 in these two.
But there's only 1 out of all 3. And it's 0 out of 1 is less than 100, and there's 2 of them, which is these two.
Exactly.
So that's
You have 2 values that are at 0.
So like we can.
So
we can
always?
work these out. So like
For because we're looking at values.
this is the same thing, but we're just looking out instead of 1 out of 1, we're looking out of 2 out of 2. So there's only 1 here where 2 out of 2 are less than 100, which is just VV. So that's just gonna be.
So then this is the proportion of the values in the sample that are under. So for this sample.
Probability where 1 out of 2 is less than 100, so how many of them have a V?
Exactly. Very good.
0 V, 1, 0, 3.
Oh, you're right. The 0 is 2 out of 3, and the 1 is 1 out of 3.
Alright.
Yeah, that looks correct. Very good. You guys are star students. So this one is 1 value under 100 out of 1 value total, which would be 1. This would be 0 values under 100 over 1 value total, which would be 0. So 0 values under 100 over 1 value total would be 0. So 2 values under 0 and 1 value is 1. Okay, let's go ahead and share the first answer. So what I'm gonna do right over here is I'm gonna write that this was a 1. I need to zoom this in. This is a 1 and these two are zeros because neither of them are under 100. So how many zeros are there? 2 out of 3. How many 1s are there? Okay, good. How do we find the mean and standard deviation of this? Let's put the values into Excel. And I have 1, 1, and 2, 0. So if I find the mean, I'm going to just do average. And that's 0.33333. And so the mean is, I'm just going to put 1/3 because 1.33333 is the mean. And then how do I find the standard deviation? STDEV. Okay, this is the tricky part. Is it S or P? We have all the samples though. P. So dot P. And then when we highlight all the values, we end up with 0.471. So this is 0.4471. Okay, this is also called the population proportion. The population proportion has this symbol P, and it's just the proportion of values in the population that are under 100. How many values in the population were under 100? 1 out of how many values total? 3. We call that the population proportion. Now let's look at sample proportions for size 2 samples. How many values were under 100 for VV? Good. Both of the V's mean that it was a value, it was value under 100? Yes. Yes. So this one here is 2 out of 2 total. What about V and R? Good. It's 1 value that's under 100 out of 2 total. So this one gets a 1, this one gets a 0.5. Anyone with a, basically what are you doing? You're counting the number of V's. So this is 1 V out of 2 values, this is 1 V out of 2 values, this is 1 V out of 2 values, this is 0 V's out of 2 values. Okay, let's go ahead and see if we can fill the charts in and then find the mean and standard deviation of both. Wow, you guys are super ahead. So how many zeros? So we're basically counting the number of V's in the sample. So like PP would be a 0,
Right.
RP would also be a 0. Yes. Can I find the standard deviation? 4 zeros, 4 ones, and 1 2. Yeah, so that's what we're starting to realize. The mean is still going to be 1/3.
How would you do this? So how do you know it's gonna be 1/3?
Okay, so there's 4 zeros in Excel, 4 ones in Excel, and 1 2 in Excel. And you do average of all the numbers to find the mean, which would be, you end up getting 1/3.
Average, what do you?
So there's 4 zeros in Excel, 4 ones in Excel, and 1 2 in Excel.
Oh, you add all those up?
You add those all up and divide by the total. And then to do the standard deviation, STDEV dot P.
Yeah, the 1/2.
Yes, it is. Oh, 1 2.
Exactly.
More, and 1 2.
Alright,
2/3.
Super, how do we know we're being? Are you sure it's not two? Does it matter if we do RR? Oh, no, it's only like, so we have R, it's not 1/3.
Because we're looking at the proportion that are under 100, or that are under $100. So those would be under $100.
Okay, so for this one, we still do the VVs, so it would be like
Be
3 out of 3, and then this is 2 out of 3.
Exactly.
Ooh, okay, so we got 2/3 for this.
We got 2/3
For both.
For both, yeah.
for both of these? Okay.
No, for both of, for the mean and standard deviation.
Yeah, we got
Okay, let's go ahead and start filling these in. This one, how many V's are there for the third one?
One.
Good, 1 out of 2, so this would be 0.5. This one would also be 0.5 because there's only one V. These has 0 V's, so 0. This is also 0. This is 0.5, 0, and 0. Okay, so this has to be 0. This has to be 1. How many zeros are there? 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9 total. And then this one, how many 1/2s are there? 4 out of 9, and there was just one out of 9. Okay, to find the mean and standard deviation, you have to put all the values into Excel. You have to put there's 4 zeros, there's 4.5s, and there's how many 1s? There's just 1. Okay. To find the mean average, what do I get for my average? Is that a coincidence that I get 1/3 again? When I find the average, I get 1/3. Not a coincidence. We should. Hopefully, we're starting to see sort of a resemblance to a problem we did before. Okay, now I'm gonna do stdev dot. All the samples are there. So it's stdev dot p. So equals stdev dot p, and then I'm gonna highlight all the values, and then I'm gonna get also 0.33333. So I got 1/3 for that one. So that's interesting. This was P again. It's not really, I shouldn't really put a label though for P because P is really the initial one out of here. Okay, any questions so far? Any questions? I'm just going to fill in the last one really quickly because I don't want to spend too much time on this because I want to get to the problems that are going to be in the homework. Okay, so this is how many V's? This is 1 out of 1. This is 2 out of 3. This is 2 out of 3. This is 2 out of 3. This is 1 out of 3. So this time I'm going to get P's that are 0, 1 out of 3, 2 out of 3, and 1. And I don't have the answer key with me, but I believe I'm going to cheat by looking at the pictures because I drew pictures that had to do with that. Okay. 8, 12, 6, 1. Yes. 8, 12, 6, 1. And these are all out of 1, 2, 3, 4, 5, 6, 7, 27. These are all out of 27. If you add 8, 12, and 6, 1, you do get 27. Okay, again, find the mean and standard deviation. See if you can find the mean and standard deviation by putting 8 zeros into Excel, 12 ones, 6 twos, and 1 1. Okay, big hint here. What do you think the mean is going to be? What do you think? Good. This is still going to be 1/3. You're going to find that you're still going to get 1/3. Let's see if we can find the standard deviation. See if you can find the standard deviation. So you have to like put an extra credit incentive. Michaela would say yes.
27.
Okay, first person to get the standard deviation gets extra credit.
Is that right?
Come on, Anderson, I know you can do it. So there was a 1, 1, there were quite a lot of zeros.
Oh, wait, no. Okay.
So there's 8,
8 zeros.
8 zeros,
And then 12.33s.
When I do my 0.33, it goes
That's
to
why I have my
January.
major.
Yeah.
And it's really stupid.
So can you just read it?
Okay, yeah, 8 zeros.
I've done like 0.33, I've done equals 1 divided by 3, still January.
Okay, okay, how about I'll just,
Stupid January keeps popping.
okay, how about I'll just do it and give credit for everyone. We know that there's 8 zeros. How many ones are there?
1/3.
Yeah, 1/3, you're right. 1/3, oh, you're right. Ah, okay,
But you can't put 0.33 and go to January again.
I know what the workaround is. You have to put equals 1 divided by 3.
1 divided by 3 is January stuff.
You have it? What is it?
For the average, we got
0.66.
0.330.
It should be still points 3333333.
Oh, it's a little off.
Okay, I'll just do it. I'll just do it. Okay, there's 12 1/3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 6 2/3, 1, 2, 3, 4, 5, 6, and 1, 1, right? Okay, if this is right, when I do average, I should get 1/3. Yes, so I did that right. STDEV V dot P, highlight all the values. We get 0.27 to 0.27 to 17. Okay. So we there's a cheat cut formula, just like last time. There's a cheat cut formula to find these values. Mean of P hat is just 1/3. Which one of these symbols is it? Let's start guessing on what we think the cheat cut formula is. Let's start plugging values in. Let's do it with the third one. Let's see if we can get 0.27217 by trying one of these formulas here. Let's go ahead and try some of the formulas and see if which ones it is. Okay. Let's up the extra credit. First team that gets the 2 answers correct will get +2 for next quiz.
We have one from last week and one from today so far.
Yeah, you're right. So right.
Yeah, I can keep tally for you.
We could just add at the end, just on all of our grades. Just bump everyone up a letter grade.
So
Full letter grade.
we have to do 1/3,
I
which was the ratio.
I think this. Just took that. It's just this.
So where do you draw the line?
Wait, is this right?
This one's right. Mean of P hat keeps being 1/3 and 1/3.
Oh, it's just P, it's just a P. Okay, we get the extra credit.
Okay,
I'm lost.
Okay.
Can we like keep tallies of this?
Yeah.
I wanna make sure I can get my extra credit.
Okay, how about everyone, we'll just take 3 extra credit points for the next quiz. How's that? Everyone.
I wrote president today.
Wow.
No, I haven't. Okay. Okay, but in order to get the extra credit, we have to make sure we share our answers. So what was mean of P hat? Was 1/3. Good. 1/3 was P. See how 1/3 right here is P. How do we find P again? We go to the population, which is V, R, and P, and it's one value that's under 100 out of 3 values total. Okay, next, This one, so we found this one, and this one happens to be this one here. Plug in 1/3 and see if you get the right answer. So if you have 1/3 times 1 minus 1/3, let's plug it in over here. This should be 1/3 times 1 minus 1/3 over blank. Plug that in to see if you get 0.27217.
So we're gonna do 1/3, or we're gonna do square root of.
What is it over?
So what sample size did these come from?
1 divided by 3.
Wait, is it-
Let's look at the samples. They were size, what size were the samples? Here are the samples. What size are they?
20. Oh.
Okay, let's see if you guys were able to set it up.
I know this one was so hard. You just sample size of 3. Oh, I need to take the right.
The sample size, what size do all the
3.
samples come from?
Sample size is 3.
Yeah, because each of the little samples was size 3.
Oh, I got it.
You should get 0.2, okay, good, 2.27, very good.
5 credit points right there.
Did you
Yeah.
do like 1/7
That's what I read. Say what?
Is it just over 3?
Yeah, it's just over 3.
And you got it too, it looks like. Good. Okay, so if we plug in, what value goes at the bottom here? What samples were each of the samples? What size were they? 3. If you plug this into your calculator, you should get 0.27217. Okay, so now we have a formula for the mean and the standard deviation of the proportion, which is going to help us construct confidence intervals. But there's one last thing we need, and that's the normal distribution criteria. Let's see if we can match up each of these graphs to which ones they were. So was this the sampling distribution for size 1, 2, 3, or 4? So let's put the labels for each of these graphs. So labels on each of the graphs.
My question is for you. Is this size,
We didn't do this.
oh, so this is just size 3. Oh, this one's called population.
Yeah, size 1 is the same thing as population. So which one? Sorry, it is. Would be the second. Exactly. Okay, let's take a vote. Which one of these do we think is the population? Number 1? Raise your hand if you think it's number 1.
Oh, wait,
yeah, I was.
Okay, which one is the population? It's the,
Which one's number 1?
it's the
Oh, the
top
bottom
one.
one's population.
The top one would be the population. Okay, let me explain why. The top one is the population because we have one value. We have one value.
Oh.
That was good, yeah, the height.
Okay, thanks. You jumped a lot, actually. So,
Why do you jump a lot?
I don't know, I like athleticism.
Right?
What can I say?
What do you do?
Okay, this is not coming out right. I like to do gymnastics. But anyway, let's not.
Oh, wait,
talk
you're-
about
Oh, gymnastics
You do,
is
like,
dope.
weights and stuff?
Do I do what?
Like gymnastic meets? Like that would
No,
be
it's all unprofessional.
Can you
stuff.
do-
have
okay,
a
what can you do?
channel for
What's
it?
the most, can you do
Can
like a back tuck and stuff like that?
you show
I
us
can't
just
do
one
anything
move?
that those professional people can do. I can do very basic.
Can you show us
Gymnastics.
one? Just one, just one.
How about if after class?
Okay. That's a compliment.
I mean, most of the gymnastic stuff I do is with the high bar.
Oh,
There's no high bar in here, so I don't know how I'm gonna figure it out. Okay, so if we go to the first one, we see that there was one that was under 100 and two that were not under 100. So that's the population. And then what's the second graph? Is the sampling distribution for size
2.
2. This one is for size 3. This one's for size 4. Okay, what theorem is starting to kind of take place here? What do we call that special theorem where we could just like put the little normal curve through it? Okay, let's see if we can fill in the blank here for the theorem. The sampling distribution for size and proportions get more blank distributed as n increases. This statement is part of the blank theorem. Yeah, it's more normally distributed. Very good.
The equal something.
Equally likely? Equally likely.
It's called the central limit
Oh, that's a
theorem.
model.
Central limit theorem. Things start to go towards the middle and it becomes more normally distributed. Okay, well now we can make a confidence interval because what was the criteria for the confidence? What theory or what distribution do we use for confidence intervals? Normal. So was that criteria met? As long as your n is big, because these get more normally distributed for big n's. So we want to use big n's. Oh God, can't talk today. Let's modify the confidence interval formula for the proportion. We're now going to make it for the proportion. Let's see if we can change these symbols to modify them for the proportion. Okay, groups of 2. See if we can modify that formula for the
Oh,
proportion.
wait.
Symbols.
We're not just.
Oh, it's right here. So,
Did I not give a symbol chart? Okay.
Do that as a class.
Well, let me give you some symbols to start putting in here. I should have given you some symbols. Here's some symbols that we've learned. We learned what p hat was. We learned what p is. We learned what mean of p is, or mean of p hat and standard deviation. So, sorry, p and p hat. Those are different. These are the symbols that you're going to want to use.
so along the far left, is that going to be mu p? Mu p? On the far
Well,
left?
This one is the one that's like x bar. Good.
P what? This is what? P hat?
P hat, yes.
P hat? It's P hat.
I'll try it one more.
Or hat.
Yeah, very good, Nora.
Is this still like you?
Well, we can change it to make it for the population proportion. Just like x bar.
Oh, it's like,
Just regular.
yeah, but the middle one just.
Just be P, yes.
Middle one's P. No P hat.
And then what would the slide ones be? The sigma p hat? Like,
No, that's fine. Yeah, exactly. You're right.
Oh, sigma P hat, yeah.
You want me to just tell you how to modify it?
Yeah.
Okay. Let's modify the formula. Where's my pen? That's not a whiteboard marker. Okay. We're modifying the formula. The easy one is this one here. Didn't we have something that had a sigma and a p in it? It was sigma of p hat. Good. Same thing with this one, sigma of p hat. We had one that was a mean of p hat. What was the mean of p hat the same thing as? Good, it's just p.
Oh.
And then x bar is the same thing as p hat for the proportion. So we can modify it for this. Okay, the reason we want to modify it now is because if we want to make a confidence interval. So in order to modify it for the confidence interval, we have to find all of these things. I want us to find p hat right away. Let's find p hat and then we will call it a day if we just find p hat. So we'll finish this next lesson.
Wait, what does this mean? What's one thing?
200.
So p hat is the sample proportion, and so that's the proportion that were admitted to UCLA.
So 15.
Wait, would it be 55? How do you do it?
Go see though, I like it. Have a good weekend, everybody.
So p hat is the proportion of the sample that were admitted to UCLA. What's this? What's the proportion?
Oh. Got it. Thank you.
Okay, that's right. Got it.
I got it.
It should be a decimal.
Mm.
P hat's always a decimal. P hat is always a decimal.
It's
What did you get for your P hat?
1.25.
The proportion of the sample that were admitted to UCLA.
Oh my gosh. Oh, we are?
Yeah, it's 0.25.
Woo!
Okay, the answer is 0.25. The
Let's
answer is
go.
0.25.
For 5 credit points, everyone.
Okay, how do we find the 0.25? There's 55 people in the sample that were admitted to UCLA out of 220 total, and then we'll make the confidence interval next class.
How do you know the standard deviation?
So the standard deviation is
Oh, so this is the standard. Which one do you do? Yeah, okay. So this won't be on the.
It'll be on next homework. Oh, I'll see what I can assign as far as
You
homework.
don't want to assign with gymnastics. Yeah, I'm right.
What do you guys want to see? There's no bar.
Okay, what, like, show me like a calendar. Oh, I do. Let's see. Your signature moves.
You saw me jump earlier. Does that not count?
I maxed out attempts on homework last week. Can I email you like photos of it?
Yes. What do I do? Like a cartwheel? Like
Yeah, let's do a cartwheel. I'm ready.
There's like so many chairs in here.
Look at you, I'm right there.
Why do you guys want to see this?
You guys, do it.
No, not what you guys don't do.
Okay, we're on our phones, right? We put our phones
No, I
right.
don't trust you guys.
Come on.
No, I don't want this like to be on YouTube and then it's gonna like get to all the other professors. Okay, bye.